Oh, I didn't ask period 1 who's not going to be here tomorrow. That's okay. Okay, we'll figure it out tomorrow. We are meeting tomorrow in the library at what time?
7:45.
Did I tell him to come early? Poor period 1. I don't even.
7:30.
No, it's 8. I don't know if they know to come early for breakfast. Like, I think I told them, but anyway, if you know anyone in period 1, Sean Durkin, let him know. He can spread the word. Come early. If anybody else knows anyone in period 1, Zach or Charlotte or Lucy, or tell them to come early for food. Anyway, not that Lucy. Lucy Lou. Paperclip. For right now. I'm not sure if I have more staples. I should, but they're in there somewhere weird. Okay. We should go till 12, 11:45. Some of you guys finished early last year. It might be a little bit after 12, depending on how our breaks go. Our main break is going to be in between multiple choice and FRQs. I should have extra coffee stuff up there just in case we run out. I can make a new pot. Okay. Anyway. No, apple cider is only like it's at Trader Joe's in the fall. Sorry, Lo Siento.
Are you making coffee cake?
And this thing, this castle.
I'm making coffee cake in that kitchen tonight. I'm making breakfast bake in that kitchen in the morning. I'm trying to use the school kitchen this year. We'll see how it works, whether it's easy or not. Let's see what else. Donut holes. I have to order donut holes. Okay. Anyway, if I were you, I would bring water. If you guys don't mind for me not buying water. I mean, I might have some, but bring water. If you have like water bottles, a lot of you guys do. But I will try to have like a few extra waters in case we run out. Otherwise, you guys know the drill. When are we as BC kids, anyone, everyone who can come for a free Starbucks, when are we working on grading AB FRQs? Tuesday after school. I'm going to lock the door. It's just us. We're going to powwow, get in groups. We'll kind of, just so that you guys know, those of you not taking it tomorrow, you know Monday from 3 to 7, yada, yada, yada. For those of you on Tuesday, I will basically assign different ones of you to different FRQs, which maybe you'll like, oh, I'll just choose this FRQ. So if you can come with your partner that you want to do your project with and you get assigned to an FRQ, theoretically, you could do that one for your video. Does that make sense? Did we forget everything I talked about earlier this week? Okay.
I thought you said we were doing it Wednesday.
People said they couldn't Wednesday because of youth group.
Oh, yeah, we said Tuesday.
Yeah. So if you guys want, like if you and your partner can both be here, you can both be experts on that FRQ, grading that FRQ. Now, there might be someone else with you, et cetera. Maybe you're the group of 3 or I don't know. So anyway, that's an idea as far as you'll kind of become the expert. You can ask me everything about the FRQ. Maybe you'll have some questions, but you guys are only going to be grading one FRQ. Does that make sense? So we're going to be grading and then passing, if that makes sense. And then someone else is going to be grading the next FRQ. Someone else is going to be, and so there's going to be a few people who are grading each FRQ. That way we can get it done. And you guys don't have to necessarily become experts at all of them right then. Just get one down. That's exactly what they do in the AP grading back in Florida, I think is where it usually is, with just rooms, and the whole room is a certain FRQ. So anyway, yeah. Wait. In the morning? Right after school, so like 3 o'clock, I'll kick kids out. And then during 7th period, I'll run and grab your Starbucks order. So have your Starbucks order ready for Tuesday. Okay. What else? I think that's it. You guys have the 2016 FRQs. That's what we're going to transition to. I'm going to pull the answer key up in just a little bit. We'll go one by one and see how we do. But for right now, we're at the very end of the multiple choice questions on your practice exam. I think we're around the 80s. I don't know. Corey, go. What do you got?
89, 90, 91.
I had
Anything before 89?
Yeah. Katrina had one. She needs to find it.
Mm-hmm.
I think it was 87.
Alan, what do you got?
I had 80s.
87.
Yeah, no, mine was 87 too.
Okay, starting at 86, going to 87, then 89, 90, 91. I think that's what Corey said.
Yeah, that's 91.
Okay. For those of you guys who are like, I don't have all these questions, perfect. Play with FRQs until we get to the one that you have. So, 86, the derivative. Remember, you got to fit your quantities, your information into camps. You have an original camp. That's like your y equals f of, could be p of, could be n of, could be who knows what of. But you have your y equals f of x, your original. You have your y equals f prime. It could be rate. It could be velocity. It could be increasing at. It could be f prime. That's your first derivative camp, and you have your second derivative camp. So first derivative, sine of x cubed on the interval 1.8 to 1.8. we could graph that with our window being x min, x max, right? Okay, we could graph it. Sorry, you guys are distracted. That's fine. We could graph our window with x min, x max. This is asking for how many points of inflection does the graph of f have? Two choices. Choice number one. With this window, find f double prime by taking a single derivative and make sure that you make absolutely no mistakes. Then you could graph the f double prime on this window and look for points of inflection, any zeros or DNEs where this second derivative goes from above to below or below to above, because the second derivative has to change signs. And if you're looking at the second derivative, you're looking at the y's. And so you could look at the second derivative and look, are there any zeros where it goes from below to above or above to below? Either one is a sign change. Or are there any vertical asymptotes, any DNEs, where there's also a below to above or above to below, also a sign change? That'd be at a DNE pip instead of a 0 pip. The other option, which is technically a little bit easier but harder to visualize, instead of looking at this one, is to look at this one. And as you look at this one's graph, you're looking for horizontal tangent lines, vertical tangent lines, or other DNEs where the slopes change sign, which will generally happen at the relative extrema of the first derivative. Because any relative extrema, any relative min or max of the first derivative, the slope will be changing sign, and the slope of the first derivative is the second derivative. So either way is good. Okay, number 87. A lot of you guys had questions on that one. A particle moves along. Ooh, it's motion. They give us velocity. What camp is that? Original, first, or second derivative?
First. Sorry.
Okay.
I was saying it's the second.
Integration as net change. Why? Given rate, given initial, they're asking about final. Now, hold on. What are they saying? What is the position of the particle when its velocity is first? So what do you have to do before you do anything else? Graph the velocity. Find its first 0 from x equals 0 on. Once you find the 0, that's the point that I'm looking at. That's the time that I'm looking at, because the x is equal to the t, in this case, for v of t. That's the time that I'm looking at in order to find the final position. So final position is going to be x of, I'm going to call this one, why not, a, is equal to x of 0 plus the integral from 0 to a of my v of t dt. Is that good? Make sure you're in radians, my physics people, for tomorrow.
I have 9. Except from 0 to 9.
But you must not have found the 0 of velocity.
Well, because, okay, so like, when I corrected this, I looked at, like, Mr. Calculus or whatever, and he had, like, answers to it, and his said from 0 to 9. And that's, I think that's kind of why I was confused.
Does it make sense now that you need the 0 of the velocity to plug in? So 0.6551368. So I don't know where his 9 came from. Maybe it was a different problem. Maybe the position is 9. Maybe he integrated. That'd be awkward. I mean, you could integrate with the initial, and then maybe he figured out that the position is 9 and did something weird like that. But if you're using time, you need to go ahead. Now, that's the one thing I would change. This shouldn't be x equals. This should be t equals. The calculator says x, it's a t. So maybe he did something with x equals. I don't know. I don't like that, though. This is better. Okay, now we're going to 89. Well, it didn't work. E for effort, F in success. I just... Okay, 89. Come on, go team, go. All right. 89. This graph, you could graph it. Bound in the first quadrant, but they didn't say that. They said in the x-axis, but either way, it's cut off. We know that cross-sectional slices, you have to figure out perpendicular to what? Perpendicular to the x-axis, therefore this is going to be a dx. It's going to be popping up in an equilateral triangle. Pretend that's actually equal sides, which is definitely not. An equilateral triangle. So I have dx. I need my volume equals the integral from, you could find your intersection 0 to 2. I need my area formula dx. The dilemma is using my top minus bottom as my side. I need a formula for the area of an equilateral triangle, and they did not give them to them this year. So, worst comes to worst, go back to geometry. Could you memorize this and add it in? Yes, you could, but could you also do this because an equilateral triangle has 60-degree angles? And to find the, you need base times height. You know, the base is s. You know, all of them are s. With a 60-degree triangle, you know that across from the 30 is the 1/2. Across from the 90 is the, if you're doing like unit circle, 1, and across from the 60 is the √3 over 2. So if s is my quantity, I have 1/2 s and √3 over 2s for just this portion of that little baby right triangle. So all of a sudden, I know that my base was always s. My height is √3 over 2s. I can plug into an area formula. A equals 1/2 base times height. So √3 over 4 s squared is the area formula to solve. But you could also just throw that one in your forever somewhere and be like, all right, maybe I should study that geometry formula eventually. I wouldn't for tomorrow per se, but there you go. Number 90 is given a graph of a derivative. Look at that initial condition. I wonder if they want integration as net change. Which of the following must be true? If I start at f of 0 equals 0, and if I change based on the graph of the derivative that I see, from 0 to 1, from 1 to 2, and from, I'm just thinking 0 to 1, 1 to 2, and 2 to 3. They're just kind of asking me about that. Guys, the derivative is positive for this whole region from 0 to 2, right? Sometimes higher, sometimes lower, but always positive. Therefore, f is increasing for, am I going to put, pause, I want everyone's attention. Up, 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 up. Why am I going to say that f is increasing for the closed interval from 0 to the open interval 2?
Because it's closed, because 0 is not a 0 and 2 is a 0.
At 0, my derivative is positive, right? And at 2, my derivative is 0. Could we split it up at 1? I suppose, but whatever. Okay, coming back. Heads down if you don't want to listen anymore. F is increasing that whole time, and then for this interval from 2 to 3, f is decreasing. And that tells me basically everything I need to know. Because I start at 0, whatever. Between 0 and 1, it's increasing. Therefore, 1 is going to be higher than 0. Well, that's not true. From 1 to 2, 2 is going to be higher than 1, which is going to be higher than 0. That one is true. This one, I'm going to increase this amount, increase, remember the area, increase this amount, decrease barely anything. So at 3, there's still a big, overall the net change will have been a positive net change despite this little baby negative, despite that amount of decrease. So therefore, f of 3 will be greater than f of 2. No, sorry, I apologize. I thought I was comparing to f of 0. F of 3 is going to be less than f of 2, but it's going to be greater than f of 1 because of this positive overall change and greater than f of 0. This is also not true. F of 3 needs to be higher than f of 1 because the positive displacement is greater than the negative displacement. Does that make sense? Okay. 91. They gave me height. That's original camp, right? An original height. What is the height of the object at the instant when it reaches its maximum upward velocity? Ooh. AKA, don't look for the maximum speed, which would be looking at the absolute value. Just look at the normal velocity. What's the absolute max? They don't give me an interval, so I don't really have endpoints to consider, so I just need to worry about the critical numbers, basically, and hope that there's an absolute max in there. So then, find h prime, which they did. Set h prime equal to 0. Wait a minute. Why didn't they have all that work of setting h prime equal to 0 and doing a sign chart? It's a graphing calculator problem. Graphing calculator problems, can't you, technically, if they want the maximum velocity, now careful, careful, careful. If they want the maximum velocity, couldn't I just find the velocity, graph it, and find the max? I could find the velocity, I could, careful, velocity, you might think maximum position, you'll have some issues, but maximum velocity, just find the velocity. Technically, to do the math, you'd have to find the second derivative, find the critical numbers of the second derivative, do a sign chart of the second derivative, or take your velocity, graph your velocity, and find your max. And so the max is going to occur according to this, at x equals, which is really the t in context of the problem that you have. And so they said h of x, I would do h of t, but whatever. I wouldn't call it x, I would call it a instead. That'd be a lot safer, but they're saying x because the calculator says x. Anyway, h of a, so take that, plug it in, find the height at, dun 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 dun. Second derivative equal to 0, or if you graph the second derivative, find the 0 where the function changes from above to below. Yeah, should be. Well, no. This would be the same value. You still have to plug in height because they're asking for find the, they're trying to trick you in two ways, max velocity and what is the not time height. Not time height. Well, the time needs to be not the 0 of the velocity, which is what I was about to do, because we're so used to max, and here's the original. Look at the first derivative. Remember, this is the max velocity. Did you look at the second derivative? And find the 0 of the second derivative? This is t. They graphed him. We can graph him. I don't totally mind. Cameron has a question. We'll just see who's missing at the end. Okay, hold on. Pause. Pause. What's the dilemma? What number doesn't match what's on your paper? T? T doesn't match? What's the 0? This should be the t of the 0 of h prime. Sorry, h double prime. This should be the 0 of h double prime. So if I'm just going to pause because I think there's just a lot of discrepancies. So it's okay. Let me pull it up on the calculator. I think there's time. Yeah.
Well, for this problem, if you just graph it and then just go.
That's what I was saying, but they're saying that they tried to solve it and it wasn't working. But yeah, you can totally just graph h prime though, not h, right? Good. Because if you graph h, you're not going to see the point of inflection very easily. But if you graph h prime, well, no, you guys went to the second derivative, right? Okay, so the second derivative would have been 18 t to the negative 1/2. Are we okay?
Yeah, I see why.
Oh. There's my 0. So wrong derivative? Okay. But pause and just think about it. Sometimes when you take derivatives, you'll make mistakes, and if there's a way to not have to take that derivative, it might have been safer. Yeah. Well, Kyle said he used the second derivative, so I'm doing it his way. And his way, looking at the second derivative graph to find the maximum velocity, maximum first derivative, I would find the 0 of the second derivative where it goes from above to below. But the way I explain doing it and the way the answer key is technically showing it is to graph the first derivative whose maximum I want and to literally just find the max. Okay, so let's check it. That's totally fine. I was just doing the way that I heard Kyle solving it. So then graphing. I need to make my window so I can see because there's stuff going up above. I have no idea how high I need to go, so I'm just going. Okay, so now let me go ahead and change my window to there he is. So if you looked at it zoomed out, it looked like it maybe hit at 0. But if you, what I do is I see that like in that one, I'm like, it looks like, but I'm not sure. So I need to zoom in. The other way of doing it, Lucy, is that you could have done, like for instance, you look here, you know, there's extra stuff. You go to your window, you say, I'm just going to change it to go higher. Sorry, window. I love the zoom box because the zoom box, you could have totally said, I need to know exactly what's going on here because I need the max. And so if you did the zoom and if you did the zoom box, I love that one because you could literally just go up to that 50. Oh, it doesn't let you do it on that feature. That's a bummer. Without having to guess. Because, I mean, I just say, well, this is all wasted space. Let's really get in close. But zoom box probably would have even been safer because zoom box says, please, I need to know exactly how this function is behaving. The struggle is, I bet the value at 0 was one of the answer choices. Does that make sense? Okay. All right. Anything else besides 91? And any of the multiple choice? Anything we skipped? Anything we passed? Feel free. Now's your time. Even if no one else has it, they're working, so we're okay.
Oh, the next question.
Oh, 92?
92, which is the last question.
Okay. Instantaneous rate of change. Same as the average rate of change. This is basically saying when is MVT true. Not that you needed to know that, but ultimately what's going on. So you want to do f of b minus f of a all over b minus a equaling f prime of c. Katrina, just how I would have done it. Just to be safe, I probably would have gone into my graphing calculator. Because, I mean, we all know when we start doing stuff by hand, we make mistakes, right? So I would have probably plugged in this f of x as y1. I would have then gone ahead and made y2 unselected. Let me go back to zoom standard real fast. Okay. I would have gone y1 is x plus ln of x. I would have, do you guys know you can hit the second back button and go to the beginning of any line of code? You can do the second forward button to get to the end of any line of code? Okay. Yes. I would deselect, I forgot if that was this class or another class, we figured it out. I would deselect that because that's not truly what I need for the intersection, but I want to use it for my nice little fraction, my alpha y equals. And you can do your alpha trace, your y1 of 4. I think it's faster. It might not be, but. Deselecting, I just hit the enter on the equals because I don't want to graph the original for the intersection. I want to graph the other two because I'm finding the intersection of the derivative and then the average. So then I'm coming back, y1 of 1, yeah. All over, I mean, if you trust yourself, 4 minus 1 is 3. Okay, so then coming down. I need the derivative, so 1 plus. I love this fraction bar because it just makes sure everything is what I want it to be. I have my 1 over x. I'm going to go ahead and make my window that 1 to that 4 to be super specific. I'm going to say, all right, come on, intersection, where are you? Now, it seems like it's graphing more than one thing. I'm going to check my mode real fast because I'm pretty sure I'm in simultaneous for polar area trying to find true versus false intersections. So you could do sequential if you want to double make sure that you're seeing what you're seeing. So there's one graph. And I think the intersection point occurred right around here. Are you good? Yeah. And the nice thing is, remember for the intersection, you don't really have to be too stressing about like the guess and whatnot. There's only one intersection point because it's a little bit above, a little bit below. All you need to do is answer those questions. I only have two functions being graphed. Since I deselected the third, I don't even need to worry about that. So just enter, enter, and then there we go. Dun, dun, dun. Wait, pause. They're asking for C. That's the x value, right? Okay, good. 2.16404. All right. You guys good for me to pull up the answer key for 2016? FRQ? Here, I'm going to go ahead and under practice. Do you want me to put the 2016 answers in the solution folder? Is that good?
Yes, please.
Okay. Let me see if I actually have it saved in my, I don't know if I do.
I wanted to ask on this one in particular, what if they only put this?
Put a single. I mean, it doesn't, yeah, the single line, is that all wrong? Just write the extra part
Well,
to
on
it.
this, yeah.
Just
And
write-
then on this one, like they didn't write the if part; they just wrote the formula.
Oh, okay. Got it. So go ahead and do what you do here. Just add the extra little piece for me. Thanks, bud. Oh, I do have it already. Never mind. Cancel. Habada, habada. All right, guys, it's officially in the solutions folder. So whatever we don't get done today, you guys know where to go to look at it and practice with it. But I am bringing it up in case you want to ask me a question now. Does anybody want me to go to the first FRQ? Is that okay? Okay. Sorry, it's coming. This is number 1, right? The tank? Okay. Is everybody here today? Yeah. In my jacket. It's cold all of a sudden. Which one? D? I see. It's talking about the difference between W and R. Is that like water in, water out? And W and R is the rate? Not amount? Okay, so think W minus R. Okay, quiet down for just a second, kiddos. Thanks. If W and R are both rates, derivatives of some original quantities, whatever, blah. W minus R is the derivative, is the rate. So if they're asking the rate pumped in the same as the rate removed, is there a time at which the rate pumped in is the same? If you can show that at any point the difference is positive and then negative, or negative and then positive, IVT guarantees a 0. That's the take they're taking. Now the question is, why are they taking that take? Why wouldn't they just take W of t, take R of t, subtract, plug it in the calculator, and find the 0? Who's R? Not a function. And so since R is not a function, we need to figure out what's going on. Now, even though R is not a function, do we know at least how low it'll go? At least. Anyway, we know it'll at least go 700. It could go lower, whatever, at least 700. How high is it going to go? At most, 1340. So what do we need to figure out? Is there a time at which W is above R and W below R? So what I would do is to be honest, I would graph W of t, I would graph y equals 1340, and I would graph y equals 700. Because then you can figure out, okay, here's the range of where the r's are that I know of, not to say it doesn't happen somewhere else. But I would graph y equals 700, I would graph y equals 1340, try to get a good picture of W of t with the x min, x max of 0 to 8. Now let's see what they ended up doing. That would give you a good a good way of at least thinking through the information. What they saw was, oh, well, that's easy. What they saw was at 0. At 0, like looking at the graph, W is greater than R is. W is going to be higher than that 13 whatever. And at 8, they realized that W is lower than that 700. So like, okay, well, therefore the difference must be positive at least at 0. The difference must be negative at least at 8. So therefore, well, if the difference changes from a positive to a negative, IVT says there has to be a place where the difference is equal to 0, hence where they're the same. Dun, 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 dun.
Woo! And they used for the W of 8, that was from part 2.
Oh, so you already knew what it was.
I'm asking,
Oh.
is that what part 2 was?
No, because part C is asking for, I think, the amount of water in the tank.
The tank, yeah.
That's using W. Just plain old W of 8 is the rate of the water entering at 8. Just like plug in 8. Plug in 8. Does that make sense? Because in C, you're having to go back with the difference and then try to figure out the amount. Remember, the amount of water in the tank is very different than the amount coming in, the amount moving. And the W of 8 isn't even an amount, it's the rate.
Is the what?
W is the rate. It's how fast. It's not the amount. The integral of W.
You just plug in to that. You said just plug 8 into that.
Because they're asking, is there a time when the rate? They're not asking for amount.
Oh, and the interval is amount. Okay, so that makes sense.
Yeah. Sorry, does anybody else want to look at the answer key for number 1? I didn't mean to steal it from you. Yeah. How are you doing? You doing better? Does anybody want me to go to number 2? You ready?
No.
Oh, okay. Sorry, a couple of you are still looking at number 1. You can grab out the calculator too. Like, guys, this isn't due tomorrow. It's not due. Like, we're just practicing. Yeah, we're just practicing. Lucy. They're saying in letter D, rate. So we're not integrating, we're not deriving. Just what we have is rate. So we're dealing with W's and R's. And they're saying the rate at which the amount of water in the tank is changing. So we have to take into consideration the rate at which water's coming in and the rate at which water's coming out, because put those two together and we can see the overall change inside. So in order to think about the overall rate of change of, we can call it A of t, the rate of the amount. A of t is going to equal W minus R.
I guess it's the same thing. I did W of t equals R of t.
Which is good, except the problem is without something with R, like without some function of R, how are you going to know if it actually, like to find that place is going to be impossible. Whereas just take a step back and say, okay, what's really going on? Okay, we're subtracting the two. So if we're subtracting the two, like if you were to move it all to one side, be like, well, okay, I can't figure out when it's 0, but I can figure out if there's a sign change, IVT, using what I do know of W and of R. Does that kind of make sense? And by graphing W, you see where it goes. And by graphing the 13 and the 7, if you can see it goes above the 13, below the 7, figure out the time, because at that time it needs to be above or below specifically. But if you can find the time where it's above, and if it was one of the tables, which it did, it was just 0 and 8. They made it easy so that you didn't even have to look at the in-betweens. But if it was above and was below, you're like, oh. It had to have a sign change somewhere. So it wasn't bad to think of that if there's nothing to do. It all to one side. And then think 0, oh, sign change, oh. Alan.
Just a general question.
Go ahead.
On the AP, is it bad to, like, when you're writing explanations to abbreviate some things? Or?
Totally fine. IVT, EVT. Using MVT instead of roles, totally fine. Using roles instead of MVT, don't you dare. We're in big trouble. Using P sub for a Taylor polynomial approximation, totally. Using INC for increasing, decreasing, totally fine as long as you give me a noun that's not it. F is increasing, F prime is increasing, V is increasing. Continuous, CONT, totally fine. Differentiable, DIFF, totally fine. Careful using too many more. The at symbol, totally fine. Plus for positive, minus for negative, totally fine. Just be careful. And do not write that it. US, yeah.
So can you just assume that WT minus RT is I know RT.
I mean, this is a real life example.
RT is a differential. I know that.
It says where RT is different.
I mean, we know that WT by the function, just by nature of the function, is fine. And so they didn't, since they didn't state any problems, like in the real life example, so by the function we can tell that, and then R, it states it? Yeah, R, it states it, so we're okay. Okay, now can I go to 2?
Yes, kind of.
Okay. It's on the Google Drive. If you guys have your phone, feel free to pull it up. I don't mind. I put it up there. It's under solutions on the practice exam.
Oh, I was right.
How do we like this format of just having questions and trying? Some can go faster if they want, some can go slower. Okay. You don't know? Like, it's good and bad all at the same time. Oh, so it's hard to look up and not to. It takes some discipline as far as not looking. Right. And force yourself to be like, I couldn't look any other time. So I'm going to force myself to try and be okay with maybe having to scratch it all out later and be like, well, what should I have done? Yeah. But isn't that a life thing too? Like, let yourself dig into your weaknesses because otherwise they'll never become strengths. It's hard though. Sorry, Caroline, I'm all yours.
It's not like a specific FRQ.
That's okay.
But, could you go over like going from like the graphs of like like graphing?
Yes. But let me do it 2 different ways because so far the AP tends to do it 2 different ways as well. I'm not going to do a graph of a second derivative, not that it never happens. It's usually a multiple choice, though. I haven't seen it in FRQs, so it's not as specific. These are the different ways that you see it. You can either be given the accumulator function, and you're given the guy inside the accumulator function, but they're asking you about the outside. Or they can literally state, hey, he's a derivative, look at his original. Okay. Let's assume Let's get you guys ready for the hard stuff. Okay. Let's make this -4. Let's make this -2. I'm just showing that because remember how they tell you like exactly where things happen. Let's make this 0. Let's make this 5. And let's make this 3. Okay. Let's assume that, not assume, but given f is continuous, this one we'll assume they give you more or they make it geometric, or I don't even know. Something. Okay. In general, what do we know? In general, okay. In general, if we want to think about increasing, decreasing, and or relative extrema, we're going to think about the slopes. Nope. The y values. We're going to think about the zeros, the DNEs, and the above, below. Yeah, Katrina?
You never went over when you see your thing.
Oh, I even have my grade book ready to do it. I just lost track of time.
Oh, well.
Okay, when you after school, like if I had
here's some.
yours on it,
Yeah. Honor system, give me a thumbs up if you honestly at least tried to do some of what you think. Honor system? Okay. Okay. I mean, do the hand. It's all right. If you guys have questions on it, feel free. I can post the answer key, like unanswer key. But remember, it's not magical. It's not perfect. But yeah, you can come. I'll be here after school. Yeah, I could keep going. I don't think I have to use the board for anything. That's a great question, though. The accumulator one gets hard.
But if I like do this in English,
No, it's okay.
is this g of t gonna be the derivative of f?
Yes.
Yeah.
Because if they want, I was going to write with the increasing, decreasing.
Yeah.
You need f prime.
Right.
Take the derivative of both sides.
Wait.
The derivative, because find f prime, right? I need to take derivative, take derivative.
Oh, it's just gonna be g of x. Right.
And if it was an x squared, it'd be g of x. There you go.
I was holding on to it for a couple of days because I had some questions on it, but I figured them all out.
Oh, you can come
Most
grab
of
it for
them.
me after school, but I'll get the grade.
Okay, all right, thank you.
Thanks, Brendan.
See?
Yeah, okay.
Oh, sorry. Go ahead.
Oh, perfect. So I can write down what you credit. And email it to me, phone number. I'll just write it. So your 72 is there you go. 62. Sorry, Emily, I'll erase it from yours.